Everyone, welcome back to the channel. I hope you guys are doing pretty well. So we will see today's daily challenge on Leetcode and we will try to solve it together. So today's challenge is again a binary tree problem and it is a medium kind. So let's see the problem statement: maximum product of the splitted binary tree. So you are given the root of a binary tree and you need to split the binary tree into two trees by removing a single edge. Okay, so what will happen is that after you break one binary tree into two trees by removing one edge, you will get two trees, and those two trees you sum the sum you find the sum of all the nodes. Okay, and you find the product of those sums. Now if you do this for all possible edges, okay, all possible edges, if you do that, is all possible splits, all possible two splits, if you take whichever is gives you the maximum product, you need to return that. Okay, so you can read the problem statement. uh, Given the root of a binary tree, split the binary tree into two subtrees by removing one edge such that the product of the sums of the subtrees is maximized. Return the maximum product of the sums of the two subtrees. Okay, so the answer may be too large, return it modulo 1 plus 7. You need to maximize the answer before taking the mod and not after taking. Yeah, so whatever. So basically I hope you do understand the problem statement at least. So uh, if you are having such a kind of tree and if you decided to remove this node, you will be remaining with a tree, two trees, two subtrees, which will be looking like this. Okay, and let's say the sum of all the nodes in this subtree is x, sum of all the nodes in this subtree is y. You find the x into y and you keep maximizing this. If you remove this node, this node, this node, for all the nodes if you remove, what will be the maximum value of this product, you can just calculate. Okay, so yeah, how to do that? The first thing which comes to mind is that one thing we can do, uh, let's say we found the total sum of all the elements in a binary tree. Okay, if I know the total sum of all the elements in a binary tree, okay, and I found the partial sum, somehow I found the partial sum. Okay, so what will be each and so let's say somehow I find out y. Okay, so what will be x? So if you know total, if you know y, you can find x to be total minus y. Okay, and for x into y, what you need to do, it is nothing but y into total minus y into x. Okay, so if you try to maximize this, so one time you do a DFS traversal to find the I mean all the sum of all the nodes. Okay, and store it in a global variable total. Okay, now that total you can subtract from the partial sum to get the other part of the other subpart sum, and multiply it and store it in a max variable. Okay, you can update your max as you used to do usually. Okay, max of mx comma y into total minus y. Okay, you can do something like this. Y is the partial sum. So yeah, I hope you can do this, and I know I mean I am assuming you know how to find the sum of all elements of a binary tree. So what you do basically at each step, mm, you calculate the sum of, so see, this is a root, so you tell me that root arrow val, so take the value from this root, let's say it's 4, so you take 4 and then you call the same sum. So if you are doing a function DFS, then you call that same DFS for if you initially called for DFS root, you call the same DFS for root arrow left. Okay, and plus root arrow right. Okay, so basically what you are doing is that you are finding you are telling your left subtree. So uh, let me show it clearly. If you are telling your left subtree that, hey, give me a return of the whole left subtree, and you are telling your right subtree to give me a return of the sum of all values from the right subtree, and you are adding those two values with your current value. Okay, you are adding those two values with your current value to get the total sum, and at every point you do that. Okay, so when you are at this point, you see, when you are at this point, this particular point, you tell your left subtree and right subtree to return the whole value, and when you have this value, you are ready to return to this node. Okay, so that's how basic recursion and DFS works. I hope you already know that. And see, one thing you can also do while calculating this sum is that, see, one time you iterate it and find out a total value, right? So when you are, let's say, uh, when you are at this particular node, okay, when you are at this particular node, you can calculate sum to be the sum of whole of this. So that will be nothing but root arrow val, as I told you just now, plus this DFS of root arrow left and root arrow right. So left subtree sum, right subtree sum, as well as the current node sum. So that will give me this subtree whole, okay. And what you can do, once you have got the sum of this whole subtree, you can act as if this node is getting broken right now, okay. When you are at that root, the path connecting to that particular root and the parent, the path connecting to that particular root and the parent, you can act as if that is getting broken. Then what will be the case? If you already have the total and you have this whole sum, so you can update your maximum, as I told you, to be something like uh, total minus this sum, okay. Total minus this sum means this whole subtree sum multiplied by this whole subtree sum, okay. So I hope you do get it now, and if you think you can solve it, you can just go ahead. So one time a DFS traversal you need to do to find the total sum, and the next time also when you are calculating the sum, you take every subtree sum and act as if that particular root and its parent node that connection is broken, and you find the maximum value, okay. You find the maximum, you update the maximum to be total minus sum into sum. That will give you our all possible two splits, what is the maximum product that which is possible, okay. So I hope it is clear to you, not at all difficult, and this problem is, I guess, not very difficult. So very easy only. So what you can do, you can write one BFS to find sum, okay. So you have this, and you can find one BFS to have sum. So if you can write the base case, if it is null, my sum will be 0 obviously. Otherwise you can simply return this root arrow val plus find sum. Instead of DFS, I am doing find sum, root arrow left. You go to the left subtree and do the same thing all over again, which will give you the sum of all elements in the left subtree, and also do the same for the right subtree and add it to the current value. And when the final root will return that means that it is returning the sum of all elements, okay. So let's say you keep this as long, okay. I have done not done hash define long, right? So let me do something hash define ll long, because you see the product, if you see x number of nodes, so sum of elements can be 5. See, number of nodes is maximum 5e4 and node value is 1e4. So one total, the sum can be of the order of 5e8, and 5e8 into 5e8, it will always be in the range of long, okay. So you can just calculate your answer in long and do a final modulo 1e9 plus 7. That will give you the same thing, okay. So you return this find sum, and let's say you have a total global variable, okay, which you want to use later on. So you can update this global variable right now. So total is nothing but you just find sum of this root, okay. So you find sum of this root and get the total, and now what you can do is update max, sort of, okay. So you can keep this maximum value 0, and you can write a void function, no, not a void function, or you can write a function update max. What it will do, it will take the root and max, and it will just update the maximum value, and at the end you can simply return maximum modulo mod, where mod is nothing but 1e9 plus 7, okay. So md is nothing but 1e9 plus 7. You can keep this as an integer, no problem for that, and just you need to write this update max function, okay. So you have the tree node star, which is okay, root, and integer max, not integer, sorry, long max. And yeah, so what do you do for this? If root is null, you need to return just, right, or return 0 only. Okay, so basically I will do the same thing as this, but a little bit differently in the second order traversal. So what I will do, I will calculate the partial sum also. This is the partial sum. Okay, and this value is giving me something like this only: root arrow val, find sum, root arrow left. So see, this partial sum becomes the full sum when it is the root node. Okay, when you're talking about the root node arrow val, as well as the left subtree and right subtree, then that will give you the total sum. But this recursion will also happen for lower depths, right? So for the lower depth, it will give you the partial sum. So find sum of root arrow right. We have the partial sum with us, and we can now simply update your answer max of sum into so if we keep this sum long, then no typecast and all we need to do. So simply sum into total minus sum, and you can just return this. I hope this works fine, or we need to do some debugging that we will check later. I hope this should work fine. Let's see, let's try to run and check. I hope you do get the solution. So okay, so you need to return also, right? So this is same, doing the same thing as calculating the sum. So I will choose to return the sum, which I forgot. So let's try to run now and check if there are more bugs. So yeah, we get a 0 answer. Why this is happening? If we try to see, max we are passing 0 and we are updating passing the copy of the variable. So we need to pass by reference, because if we want to change this same answer, max, and we are returning that only, so we need to pass it by reference. Okay, so now if we try to see, it is still giving a 0 answer. So if we try to just check why is that happening, max is this sum total minus sum. Total is very clean, I guess. It's just total root arrow val, find sum, root arrow left and right. So this definitely has the total sum. And when you are trying to update the max, if the root is null, just return 0. And you calculate the partial sum, root arrow val for a particular node, find sum for left and right. Okay, so why will you do find sum? Okay, you want to update call this function, right? So yeah, that is obvious. So a silly mistake, you can say. You can update max and pass this maximum value also. Okay, yeah, and you need, doing while backtracking, you can just subtract the partial sum from the total sum, as well as multiplied by the partial sum. You can get the sum of the two parts and multiply those sums and update your maximum. I hope this should work fine. Let's see. Yeah, you see, we got the accepted thing, and if we try to submit it, I guess runtime will also be pretty decent, because yeah, I'm not using any extra space, just calling a DFS 2 times. So you see the runtime is also like 100%. And if you try to analyze runtime complexity, you will get a simple O of n solution of the order of the number of nodes. So yeah, that's all. I guess that's all for this video. I hope the problem was very clear to you. I will say it was not at all difficult problem. It was slightly on the easier side, but more kind of medium problem. So yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.